Hello everyone. Today in Math 20-1's Adventures, we're doing Unit 3, Part 1, Radical Expressions and Equations, and we are doing Lesson 4, Dividing and Rationalizing the Denominator. And we're going to learn what that means, rationalizing the denominator. So, recall the division property of radicals, similar to the multiplication property of radicals. So if we have the root of a over b, it is equal to the nth root of a over the nth root of b, where n is a natural number and a, b, root of a and root of b are in the real numbers, and because we have b on the bottom of a fraction there, b cannot equal 0. Okay? So basically what that means is that if we have two radicals and they are the same root, same index, and they're dividing, we can divide them through. Now we had to deal with this a little bit when we did quadratics, when we were using the quadratic formula or we were completing the square. So you talked about rationalizing the denominator already, but now we're just going to focus on that. So this should seem a little familiar. It's just a little more intensive. So simplify the following. Because we have square root of 8 over square root of 2, we can, and they're the same index for that root, we can just divide those two numbers. So this would be the equivalent of square root of 4, because 8 divided by 2 is 4, and we can solve for that value and get 2. Now, I can show you how that works another way. If I look at 8, I can, if I want to change it to a mixed radical, it would be equivalent to 2 root 2 over root 2. Well, then looking at that, on the top and the bottom, I have root 2 over root 2. So those would divide out, and I would get my answer as 2. Okay? But it's simpler just to divide those numbers under the radical than doing that whole switching to a mixed radical. Looking at the next one, again, we have 4 cubed root of 6 divided by 2 cubed root of 2. So we can divide the two coefficients, 4 divided by 2, and get a 2. Remember, it's a cubed root. Because it's the same index, they're both cubed roots, I can divide 6 by 2 and get 3 for my answer. Okay? Now, that's recalling our division property of radicals, but some situations we have, so for looking at this example number 1, consider 5 over 2 root 3. Now in this situation there's no radicals to divide. Also, we notice it's not a rational number because root 3 is irrational. When we're simplifying division expressions, we do not want to have a radical in the denominator. So this is a situation we do not want to have. So what we can do is we can multiply the numerator and the denominator to get rid, or we want to ask ourselves, what can I multiply the numerator and the denominator by to get rid of the root 3? Well, root 3 times root 3 equals 3. So if I multiply the top and the bottom by root 3, I'm going to be able to get rid of that radical on the bottom, like so. 5 over 2 root 3. If I multiply the top and the bottom by root 3, on the top, I'm going to get 5 root 3. On the bottom, I'm going to get 2 times 3 because if you recall from up here, root 3 times root 3 equals 3, right? So that's what I've done on the bottom there. Now I'm not done. I'm going to simplify this further. 5 root 3 here, and 2 times 3 is 6. Now, sometimes you can simplify that further. In this case, there's no common factor from the top and the bottom, so this would be my final answer. Okay? Now, the process of converting a radical expression so that it has no radicals in the denominator is called rationalizing the denominator, because we don't want an irrational number in the denominator. We're now rationalizing it. And this is considered the simplified form. So this is the form that if you're asked to simplify something, if you've got a radical in the denominator, it is not in simplest form. So you want to make sure that you put it in simplest form by rationalizing the denominator. Okay, so let's do a few examples. And in this case, I might ask you to pause periodically and try them on your own. So looking at the first one, I want to ask myself, well, I have a radical in the denominator, and I'm going to want to rationalize that. So I want to multiply the top and the bottom by the same radical in order to rationalize it. So I do so by multiplying it by root 5 over root 5. Because when I multiply the root 5 on the bottom by root 5, I'm going to get 5. Okay? Now it's important to note that on the top, treat it like it has brackets, because you have to distribute on the top. So if I rewrite this, root 5 over root 5 times 4 root 5 minus 2 over root 5. And then I remember to distribute to both terms in the brackets. What I'm going to get is, multiplying the first term, I'm going to get 4 times 5 minus 2 root 5, okay? And on the bottom, root 5 times root 5 will leave me with a 5. Now, not quite done. 4 times 5 is 20 minus 2 root 5, and it's all over 5. Again, there is nothing common to all of these, so this would be my answer, okay? Sometimes you have a common factor. In this case, you do not. Looking at the next one, I'm going to simplify the denominator, because it is not it can be changed to a mixed radical. So I'm going to leave the 9 root 2 minus 3 root 5 up top. 12 has a factor of 4, which is a perfect square, so that means I can take the square root of 4 out, which is 2. So I'm going to get 2 root 3 from the 12. Just to recall, for those of you, that's equal to 4 times 2. So the 4 will come out, and it'll become a 2 root 2. Oh, root 3. My apologies. All that, and I used the wrong number. Okay, 4 times 3. There we go. So that's what I did for the bottom. And it just makes it simpler. It means we're going to multiply it by a smaller radical. So that means that we want to multiply the top and the bottom by root 3. So if I have root 3 over root 3 times, and again, watch the top. We want to put it in brackets so that we remember to distribute, all over 2 root 3. I multiply through, distributing to the top. And I'm going to get, and I'm going to just draw a line here so we can see the differentiation. So I multiply coefficient by coefficient and radicand by radicand. So on the top I'll get 9 root 6 minus 3 root 15. And on the bottom I'll get 2 times 3, because root 3 times root 3 is equal to 3. Now I'm going to simplify this. So 9 root 6 minus 3 root 15 all over 2 root 3, which is 6. Now I ask myself, what number can I divide out of all the terms? They're all divisible by 3. So I'm going to divide all of these by 3. I get a 3 here, a 1 here, and a 2 there. 9 divided by 3 is 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. So I'm going to have 3 root 6 minus root 15 all over 2. And at that point, it is now in simplest terms. There's no common factor, So that one is done. Okay, so common, oops, I'm not going to write in yellow because we won't see that. Common factor. When they say simplest forms, they want common, and you have a common factor, you want to take that out. Okay, so let's take a look here, next two examples. This first one's got a little bit of work to do first because we want to change these all to mixed radicals. 24 is the same as 4 times 6, so I can take a 2 out, so it'll be 2 root 6. Square root of 4 is 2. 48 is 16 times 3, so I can take a 4 out, so 4 root 3. And minus 108. 108 is 3 times 36, so it's 6 root 3. Now, I know that because I have my notes sitting next to me. Don't panic if you have to pick up your calculator and figure out a few factors. If you need more room, sometimes that happens. Sometimes you don't know off the bat, and when you start dividing, you can factor and figure out. Think about, though, those perfect squares. It will save you some time. On the bottom, we'll still have a root 6. So that is what we're going to times the top and the bottom by. However, if we notice up top, I can simplify that expression because I have like terms. Okay, so let's combine those like terms first before we do any multiplying. So 2 root 6, I have plus 4 root 3 minus 6 root 3. So that is negative 2 root 3, and again, all over root 6. I'm going to times the top and the bottom by root 6 over root 6. Don't forget about distributing to both terms and on the top. So it's, for many of us, it's helpful to draw in those brackets. It helps remind us to do that. When we distribute, multiplying that root 6 by both terms in that bracket, we're going to get, first we get 2 times 6 minus 2 times root 12. And on the bottom, I'm going to get root 6 times root 6 is equal to 6. Now again, we ask ourselves, or let's simplify. I'm going to get 12 minus 2 root 12 all over 6. I'm going to ask myself about common factoring. What can I take out of 12, 2, and 6? I can divide out a 2. So this will be 6. This, I have another step. So this will be correct in your notes key. So let's just erase this step here for now. Hopefully you all did that in pencil. Because I noticed here I've got a 2 root 12, so I can simplify that further. So I have 12 minus, with the 12 I can take out a 4, or it's 4 times 3, so I can take out a 2. So 2 times 2 is 4 root 3 all over 6. Now I'm at the place with common factors. What can I common factor out of each of these terms? I can divide out, I can divide out a 2. So 12 divided by 2 is 6. Negative 4 divided by 2 is negative 2. And 6 divided by 2 is 3. So I've common factored, so that would give me my answer 6 minus 2 root 3 all over 3. Now, you may look at that and say, but miss, can't I divide 3 out? Well, no, you can't, because this 3 here is under the radical. So you can only, when you're dealing with numbers that are not radicals, you can't just divide them. So this is as simple as it gets. Okay, we can't divide that 3 out of the top and the bottom. Okay, and let's do the last one. 7 plus root 7 over 7, or 3 root 7. So I'm going to multiply the top and the bottom by root 7 over root 7. Okay, I still have to distribute, so don't forget to do that. So when I multiply through, I'm going to rewrite it down here, root 7 over root 7 times On the top, 7 plus root 7 over 3 root 7. And I'm going to distribute to everything in the brackets. And I will get 7 root 7. Oops, I forgot to change my color. I will get 7 root 7 plus root 7 times 7 is 7. Oh my gosh. My apologies, guys. You tap something lightly and it flips. So let's go back to this. So root 7 times 7 is 7 root 7. Root 7 times 7 is 7. All over. And on the bottom, I'm going to get 3 times 7. So before I even multiply, I can see that 7 is a factor for all of these. So I can divide that out. 7, 7, and 7. It wouldn't matter if you multiplied the bottom and factored it out after. You'd still get the same answer. But by doing that, I now get root 7 plus 1, because 7 divided by 7 is 1, all over 3. I think like a mathematician, so I always look for the shortest pathway. And just looking at that, I could tell in this step that I could divide a 7 out of each of them. Again, if you multiplied through and then divided your 7 out, you would still get your same answer. Okay? Recall. Remember last lesson where we talked about conjugates? Sometimes we might have a binomial in our denominator and we still want to rationalize it. We can use our knowledge of conjugate expressions when it comes to radicals to use that same strategy we use with difference of squares to get rid of the radical. When multiplying conjugates, the result doesn't have a radical because that middle term will subtract out. So we can use these conjugates to rationalize the denominator if we have two terms in the denominator. So let's see exactly how that works. This is, for those of you who kind of go, oh, math, crazy. This is one of those things that makes your life easier. So math can make your life easier, okay? So looking at this, what we have to think about is we have to think about the conjugates. And we just have to think about the conjugates of the denominator because we're going to multiply the top and the bottom by that conjugate. So looking at the first one, if I just look at the denominator, the conjugate of the denominator here is, if it's 3 minus 2 root 6, it's going to be 3 plus 2 root 6. And I'm multiplying the top and the bottom by exactly the same expression because that's like multiplying the expression by 1. You can't have something different on the top and the bottom because then you are changing the expression. Here, I'm literally just multiplying it by 1. I've just written 1 in a different way. So when I multiply through, on the top, I'm going to have to use FOIL. So on the top, I'm going to get 9 root 2, because that's 3 root 2 times 3, plus my outer is going to be 6 root 12. My inner is going to be negative 6 times 3, which is negative 18. And my last is going to be negative 2 times 6, because does that make sense? First, outer, inner. No, that doesn't make sense. I made a mistake. That is going to be, my last will be minus 12 root 6. Okay? So that would be my top. Now on the bottom, because I'm multiplying conjugates, I basically are just multiplying each term and subtracting them. So 3 times 3 is 9 minus 4 times 6. Okay? Now I need to simplify the top. I'm going to have to simplify these expressions and just see what's going on with them. So 9 root 2 is in simplest form. 6 root 12. 12 has 4 as a factor, so I can take a 2 out, so it'll be 12 root 3. Minus 18, and then 12 root 6 is in simplest form. And then on the bottom, I have 9 minus 4 times 6. 4 times 6 is equal to 24, so 9 minus 24 is minus 15. Now, looking at that, I can factor out a common factor because I can factor out 3 from everything. So 9 divided by 3 is 3, 12 divided by 3 is 4, 18 divided by 3 is 6, and 12 divided by 3 is 4. And on the bottom, negative 15 divided by 3 is negative 5. So I've common factored that out, and I'm going to be left with 3 root 2 plus 4 root 3 minus 6 minus 4 root 6 all over negative 5. It isn't pretty, but that's what it is. Okay, let's give a little divider. I'm going to get pretty squinchy with the next one. My apologies. I'm actually going to probably start it a little higher up so that it can fit it in here. So for this one here, looking at it, we have to multiply the top and the bottom by the conjugate of the denominator. Okay, so that means we're going to multiply by the conjugate of the denominator is 2 root 6 minus 4 root 3. So it's the same terms, they're just subtracted instead of added. So same thing on the top, 4 root 3. Okay, on the top we have to FOIL. So when we FOIL, we get 10 root 18 minus 20 times 3, because 5 times 4, and then the 3 goes away, plus 2 root 12 minus 4 root 6 all over, and then on the bottom, we get to rationalize that denominator. We multiply each term and we just basically subtract them. So 4 times 6 minus 16 times 3. Okay, I am squinchy, sorry. And I did that again. Okay, so let's simplify the top. 18 has a factor of 9, so I can take a 3 out. So I'll get 30 root 2. 20 times 3 is negative 60. Here I can take a 4, 12 is a factor of 4 times 3, so I take a 2 out. So I'll get 4 root 3, and I can't do anything with the 4 root 6. On the bottom, 4 times 6 will give me 24. 16 times 3 is negative 48. So I'm left with negative 24 on the bottom. Again, I look for my common factors. They will come up. And I can divide out from all of these, I can divide out 2. So this will be 15, this will be 30, this will be 2, this will be 2, and this will be negative 12. So from that, I actually squinched it all in. So we have 15 root 2 minus 30 plus 2 root 3 minus 2 root 6 all over negative 12. And let's put a box around it so we know that's our answer. Because there's not a lot of space for all this work. And sometimes there is that much work, though, to do them, so just bear with that. You're doing a lot of expanding, and unfortunately, radicals take up a little more room than other things do. Next one. Now, the next one only has a monomial at the top. That's going to simplify some of the work we do. but we still want to rationalize that denominator. So we're going to multiply the top and the bottom by the conjugate. So here is a moment where I'm going to ask you to try this one, and then we'll go over it together. So pause, and once you're done, come back. So press pause now. Okay, and we're back. So we want to multiply the top and the bottom by the conjugate of the bottom. So that's going to be 2 root x minus 3. So it's the same expression, except we're now subtracting. So on the top, we multiply by the same thing, 2 root x. Why did I write a 3? One will never know. 2 root x minus 3. Now we still have to distribute on the top. So on the top, it's 3 times 2 root x, so it'll be 6 root x minus a 9. And on the bottom, so 2 root x times 2 root x is going to get us 4x. And 2 root x times minus 3 will be, plus 3 times 3. I don't know why I started to FOIL. I'm sorry, guys. We don't have to do that. We're mathematicians. We're going to be lazy here. So it's going to be minus a 9. Okay? Now, at that point, I don't have any common factors. I do want to point out that we want to make sure that we say that x has to be greater than or equal to 0, because if it's not, then this we can't have a negative under the radical, so we need to make sure that we've made that limitation there. Okay. Next one. Let's try this. So again, if you want to pause and try this on your own, you can do that and then get back to me. So pause. All right, and we're back. So we're going to multiply the top and the bottom by the conjugate. So x plus root 10 over x minus root 10. We're going to times it by the conjugate of the denominator, so that will be x plus root 10 times x plus root 10. Okay, same thing, top and bottom, because we're multiplying by 1. When we multiply this through, I'm going to get x squared plus root 10 plus root 10 plus 10 all over x squared minus 10. And I can combine like terms on the top there. So I'm going to get x squared plus 2 root 10 plus 10 all over x squared minus 10. So that would be my final answer. I don't have any variables under the radical, so there's no limits there. So we're good to go. Hopefully we got those right. Remember, when we're finding a conjugate, we're only worrying about the denominator. So we can apply these for some problem solving. So here we have an example with problem solving. A triangle has an area of 2 root 15 minus 3 root 6 square units, and the base is root 15 plus root 6 units. And we want to know the exact value of the height of the triangle. Well, first things first, let us draw a picture. So drawing a picture of this triangle, I have my triangle here. We don't know what kind of triangle, we're just using a random one. We know that this would be the height, and that the base from the question is root 15 plus root 6. We also know that the area is equal to 2 root 15 minus 3 root 6. And it wants to know the exact value of the height of the triangle. So let's remember our area of a triangle formula. Area is equal to base times height over 2. If we are now looking for height, let's rearrange to figure that out. So if I move the 2 over, I'm going to get 2a equals base times height. Basically, all I did was multiply both sides by 2, and it divided out on the one side. I want to get h by itself, so I'm going to divide both sides by b. So 2a over b equals h. And this is the formula I'm going to use to solve. So, looking at this, h is equal to 2a divided by b. So h is equal to 2 times our area, 2 root 15 minus 3 root 6, all over root 15 plus root 6 units. Now, in order to figure this out, I basically have to rationalize the denominator. So I'm going to multiply the top and the bottom by the conjugate of my denominator. So 2 root 15 minus 3 root 6 all over root 15 plus root 6. So the conjugate of the bottom is root 15 minus root 6. So multiplying the top and the bottom by that value. And I'm going to simplify. Now I'm going to wait to distribute that too. So we'll leave it out here and we'll FOIL. When I FOIL this, I get 2 times 15, because root 15 times 15, root 15 is equal to 15. Then I get minus 2 root 90. Then minus 3 root 90. And then plus 3 times 6. On the bottom, I get basically 15 minus 6. Okay, we're getting there. Let's simplify. So leave that 2 out for now. So I'm going to have 60 here. I can take out of this one, yeah, I can take out a 9, right? 90 is 9 times 10. So this becomes negative 6 root 10. And this becomes, same thing here, I can take out a 9. It becomes a 3 when it comes out. So it'll be negative 9 root 10. Plus 3 times 6 is 18. Right? All over 15 minus 6 is 9. Okay. So let's keep simplifying. And I'm probably going to go over onto the next page, but bear with me. So simplifying this further, 2 times, well, 60 plus 18. Why did I get 60? This is actually 30, isn't it? You're probably all saying, Miss, where did you get 60 from? And I don't know. 30 plus 18 is 48. And here I have negative 6 and negative 9. Which is negative 15. Negative 6 and negative 9 is negative 15 root 10. And it's all over 9. I made a mistake in my notes again. You know how I do that. I just want to double check my work to make sure I did it right. I see what I did in my work. Okay, so this should be correct. Now I'm going to distribute that too. So I'm going to get 2 times 48 is 96 minus 30 root 10 all over 9. So that's a 9 there. I'm going to move down to the next page, or over here. I'm going to move it down, guys. Sorry, because it's just squinchy. So follow where I go. I'm going to move. Let's move from here over to here. So H is equal to, what did I say? 96 minus 30 root 10 all over 9. And I can divide all of these by 3, okay? So if I divide 3 out of each of these, 96 divided by 3 is 32, 30 divided by 3 is 10, and 9 divided by 3 is 3. So for my final answer, it's 32 minus 10 root 10, so 10 root 10 all over 3. Ugh. And that is our height. So with dealing with these, you got to get it out of your head that you're getting one number. And I'm sorry for my pauses in there. I just made a mistake in my notes, my key works, and I was fixing it on the fly. This should be correct. It looks good to me. The big thing is rationalizing the denominator. You have the skills for rearranging formulas, so you should be able to approach problems like this. Start by rearranging the formula like we did up here, where we put it in the form h is equal to 2a over b, and then substituting in what you know and rearranging and solving. Okay, so, and you know me, those of you who know me, but a lot of math teachers, they want you to draw a picture, sort out the problem visually. It helps a lot when you are solving the problems. Now the next one is a your turn. So let's read through the question. When the denominator is rationalized for this question, root 10 minus root 2 over root 10 plus root 2, and you can express it in the form, the answer can be expressed in the form a minus b root 5, where a and b are rational, and the value of a plus b to the nearest 10th is. So first thing we have to do is we have to rationalize the denominator so we can get it into this form. When we get it into that form, we'll find a value for a and b, and then when we have those values, we can add them together to solve our problem, okay? And it says to the nearest 10th, so you know to do that. So you're gonna pause, you're gonna try this on your own, and then press play again and see if you got it right. So press pause now. All right, and we're back. So first step is to, 1, rationalize the denominator. That's what it's asked us to do, okay? So we're going to take root 10 minus root 2 all over root 10 plus root 2. Now we look at the denominator, rationalizing this denominator. It's basically root 10 minus root 2, and the same thing up top. It's got to be the same thing in this fraction so that we're multiplying by 1. Then we're going to multiply through. On the top, you're going to have to FOIL. So root 10 times root 10 is 10. Root 10 times root 2 is, or negative root 2 is negative root 20. And negative root 2 times 10 is negative root 20. And then negative root 2 times negative root 2 is negative 2. Or it's positive 2, sorry. It's a negative times a negative. On the bottom, we're rationalizing the denominator. So we're basically just multiplying each term by each other and by itself and subtracting. So root 10 times root 10 is 10. Root 2 times root 2 is 2, and we are subtracting. Okay, next step, we're going to simplify the top. So we have 10 plus 2, which is 12. And then we're minusing 2 root 20. All over 10 minus 2 is 8. I can simplify the top further. So I have 12 minus 4 is a factor of 20. So I can take a 4 out and it becomes a 2. So it'll be 4 root 5 all over 8. Now, we want it in the form a minus b root 5. There's nothing stopping us to have fractions. So if we do that, we can split up this 8. So we can go 12 over 8 minus 4 root 5 over 8. So I haven't changed the expression. I've just basically written it as 2 terms. I can simplify those further. 12 divided by 8 is the same as 3 over 2. And 4 divided by the 8 is equal to 1/2 root 5. So if I take this and I think about this expression, a minus b root 5, well, I've got my 5, so I'm right there. So that means that a is equal to 3/2 and b is equal to 1/2. Okay? Now, what the question asks us to do is it wants us to add a plus b, which is 3/2 plus 1/2. And we're going to add those together very nicely. They are fractions with the same denominator, so we don't have to find a common denominator. We already have it. So we'll get 4 over 2, which reduces to 2. And that would be our final answer. So the first step is rationalizing. The second step is finding that formula once we have it in that form, and then finding the values for a and b so that we can answer the question. Okay, break it up into steps if you need to, because that's the best way to approach a problem. Now, your assignment, extra practice, page 119 and page 126, and there's a variety of questions there. So, check your work. Make sure that if you have problems with any of them, that you're prepared to either come to tutorial or email your teacher asking for assistance. Take a look at the answers.